right, guys, we are going to do a quick review of what's coming up for your test tomorrow. Now, as a reminder, in my class for your strategies grade, you will be able to use your notes for the strategies test. All right, so let's take a look real quick. A segment with a length of 3 inches is dilated. Remember, dilations, we always will multiply. If we multiply by a number that is greater than 1, it's going to get bigger. If we multiply by a number that is less than 1, it's going to get smaller. So here it's dilated by a scale factor of 4. What will be the length of the image? Simply 3 times 4. That's all you got to do. 12. And technically it would be like 12 inches. A segment with a length of 3 inches is dilated at a scale factor of 0.25. What will be length of the dilated segment? Again, all we're doing is multiplying, and we're going to get 0.75 inches. Next it says, let me get my calculator open, identify the scale factor if triangle AOB is mapped to triangle COD. So we're going to go from small to big. So we know that the number has to be greater than 1 for small to big. So I would say, well, this distance here is 2. My bigger triangle, the distance is 4. So we talked about it being new over old. So we're going to do 4 divided by 2, and that's going to give us our 2. So basically, we just multiply each one of these points, and that's going to give us our scale factor. In this case, it's saying COD to AOB. So we're going from the big triangle to the smaller one. So if we go from big to small, we know that our number is going to be a number that's less than 1, or technically it's between 0 and 1. So what we'll do is we'll just take our 2, because our new one is the smaller one. So now we'll put our smaller one first, because that's our new, divided by the old one, or the first one, that's 4, and we get 0.5. If C prime D prime is the image of CD under a dilation with a scale factor of 2/5, if CD is 15, what is C prime D prime? Again, we're just going to multiply. I'm going to do it the old-fashioned way, set it up like this. Reduce, and then we get 6. Okay, so CD will be 6, and that makes sense. Okay, some of you might have done 15 times 0.4, and you would have gotten 6 that way as well. Okay, next it says NOP, triangle NOP has sides of length 3, 6, and 9. If triangle NOP and RST is similar, which of the following could be the lengths of RST? So now we know that N is going to map to R, O maps to S, and P will map to T. So NOP, RST, and it tells us just in order, I'm going to put the 3 here, the 6, and the 9. It doesn't matter, it's just a sketch. So we have to think about what number can I multiply 3 by to get me here? Well, 3 times, I would do 5 divided by 3. Oh, I opened up phone instead of calculator. Nice job, Michelle. 5 divided by 3 is 1.6. So in order for me to go from 3 to 5, I'd have to multiply by 1.6. So then what if I take 6 and I multiply it by 1.6? I get 9.6. So because I don't get 8, I know I'm going to eliminate choice A. For me to go from 3 to 2, let's see, I get smaller. So my scale factor would be 2/3. Okay, 2 over 3. So if I do the next one, then I'm going to have 5. If I multiply that by 2/3, we know it's going to get smaller. I'm sorry, this should be 6. So when I do that, that's going to give me 4. Because 4 doesn't equal 5, it's not this one. Now pretend this is a 6. Well, the way I go from 3 to 6 is I multiply by 2. Okay, right? 6 divided by 3 is 2, so that would be my scale factor. So now let me look at the next one. Well, here's 6. What's 6 times 2? Well, 12. So that works. What's 9 times 2? Well, it should be 18. So then we think, well, maybe that one might be it. This doesn't work. That says 17. So let's just double check. Here, again, it gives us a 2 first. So remember when it was the 2, our scale factor was 2/3. So we've got 2/3 times, let's see, 3. That gives us a 4. So that works. No, 2/3 times 6. Why did I say 3? And then if we do 2/3 times 9, that's going to give us the 6. So this is our correct answer. So when it says, it asks you to find what could be the length, basically all we do is we multiply each side by the scale factor. And whichever scale factor works for all of them is the correct answer. Next problem. 6, given angle A is equal to angle 6 and angle C is congruent to angle D. So we're going to do A and X. Why did I say 6? I don't know. Because I'm rushing. C and Z. Which postulate proves them similar? This is angle. Remember, this is the one that you definitely have to know for the proofs. Next, we have this one. The other ones are sides proportional, angles same. Okay, so it could be if the sides are proportional, all 3 sides, it could be side, side, side. If the sides are proportional, the angles are congruent, it could be side, angle, side. A triangle XZU, so we know that X is going to match to Q, so I'm going to put a little X here, a little curve here. Z matches to S, so we can see that. Here's our right angles. And U matches to R. What is the length of SQ? This is what we're trying to find. So we do know that the hypotenuse, the 35 and the 40 match. So I'm just going to put 40 over 35. And then kind of remember, if we turn it, here's our SQ. Our SQ is the same thing as our ZX. So that's going to be SQ will be in the denominator because we want to match these. The X and the 35, I put in the 35 in the bottom, so the X has to go in the bottom, which means this 24 needs to go on the top. So basically, this right here represents the hypotenuse. This represents the side. This represents the first triangle, and this one represents the second triangle. Then we cross multiply. 40x equals password 35 times 24, which is 840, divided by 40. I don't feel like doing my head. I think it's 21. It is. So x equals 21. Down here, what proportions could be used given to show that they're parallel? Remember, this is where we match the parts. So if EA matches to AD, then we're going to stick with the top triangle again. So this is our top triangle. This is our bottom part. So then I would have EB will have to match to BF. Technically speaking, you also could say AB, which is this line, matches to this line down here. And we don't want to say match that it is equal. Basically, we're writing proportions. This is all about proportions. Next. Somehow yellow paper was in my printer, so now we have yellow. What additional information is needed to prove this piece of information? Again, we want to make sure that we map the letters just like we did in class. A matches to D. Here's A, here's D. B matches to E. B, E, and then our C's match. So we have to see, well, A, D, this is kind of how I did it in class for some of your classes. So if this says A, does A match to E? No, B matches to E, so it can't be this one. Does B match to E? B matches to E. 2 lines, 2 lines. B matches to E. Does A match to D? A matches to D, one line, one line. Does C match to C? C matches to C, so it's going to be choice B. Just to show you this one, I'm saying, does B match to A? Nope, B doesn't match to A. A and D match, so it can't be this one. B matches to C. Nope, B matches to E, so it can't be this one. So the main takeaway for this problem is you do have to pay attention to the order. The order matters. Next, solve for X. Okay, this is one where you can do the parts because the triangles are embedded. So we can do, I'm just going to pull this triangle out. This would be a 2 and a 3. And then here's our longer one. This piece here would be X. This piece here is X plus 4. So then, because we're going to assume that they're similar, so we'll do 2 over X. So 2 over X equals 3 over X plus 4. Cross multiply 3X equals 2 times the quantity X plus 4. Distribute. Subtract. And then we get our value, X equals 8. Now, as a trick, they might have asked you, well, what's it going to be down here? Well, if I put 8 plus 4 in, I could get 12. So they might have asked you that piece of information. So just kind of be mindful of what they're asking for. Are they asking for the side length, or are they asking for the missing pieces? And now you can see it works because 2 times 4 is 8. 3 times 4 is 12. So we know that we did that problem correctly. If a flagpole casts a shadow that is 6 yards long, here's my long, 6 yards. At the same time of day, we don't know how tall the flagpole is. The same time of day, a 5-foot tall woman casts a shadow that is 4 feet long. Now here's a hint. 1 yard is 3 feet. So this really is 6 yards, but really I need to convert that to 18 feet. Then you can either do X over 6 equals 5 over 4, or you could do X over 5 and match it this way, flagpole over flagpole equals shadow over shadow. Either way, you'll get the same answer, which is 4X equals 30, which is X equals 7.5. Next, dilate the scale factor with a scale factor of 2 and a center of dilation at 1.5. So basically, remember, we're going to draw long lines connecting. This one goes down 2. Well, it says scale factor of 2, so 2 times 2 equals 4. So I got to go down 4. So here's my new point. My new point is at 1, 1. Here, I went up 1 over 1. That was 1 time. So now I'm going to go up 1 over 1 again. Here's my second time. So here's my other new point. So this point is 7, 7. So this would be the dilated segment. Remember, basically, we're going to draw long lines. Okay, and then I pretty much just count boxes. I taught you other ways in class, but I pretty much just count boxes when it's on the coordinate plane. In class, what you did is you measured. Remember, you measured this using the compass, and then you moved the compass and measured it again. This time, instead of me just using a ruler, I'm just counting up 1 over 3, up 1 over 3. Let's look at another example. The segment with a scale factor of 3. Here's my point of dilation. So I'm going to draw my long lines. Actually, I should use a straight edge for this. So this would be my long line here. And then this long line would be 1, 2, 1, 2, 1, 2 here. Okay, it says that the scale factor is 3, so I have to move that movement 3 times. Left 2, down 2, this is my first time. Left 2, down 2, this is my second time. Left 2, down 2, this would be my third time. So this new point would be -2, 0. Here, it's, I wrote on this so much I can't tell. Here it is. Down, or right 1, down 2 is my first. Right 1, down 2 is my second. Right 1, down 2. This is my third. So this point is my line. 7, 0. That may be wrong because I might have not seen what the line is. So I wrote so much over it, I have no idea what the original one is. What do you notice about the pre-image and the image? I would say that they were larger because the scale factor was greater than 1. And again, this one I'm not so sure about simply because I wrote over it and I don't remember what the original line looks like, but we'll keep moving on. You get the idea of how to do that problem. Number 15, in the triangle shown below, it's dilated by a factor of 2/3 to form X, Y, Z. Given that A is 50, B is 100, what's this measure? This is a trick question. Okay, this is a trick question. Dilations only affect sides. So all we're doing is we're knowing that these match here. So 180 minus 100 is 80, minus 50 is 30. So the answer is 30 degrees. Do not use the scale factor. Okay, this is a trick question. Scale factors only deal with sides. Remember, the angles are congruent. Okay, number 16, write a similarity statement for ABC. Okay, let's see. Ooh, it's not even easy. Well, this right here is our longest side. So let's just look at our longest side. This right here is our longest side here. So I would just compare the longest sides. So A is between the middle side. Here's our longest. Here's our middle. Here's our smallest. I started giving you scale factor. I realized I messed it up. Here's our longest. Here's our middle one. Here's our smallest side. So if we think of A, well, A falls between our longest side and our middle side. So our longest side here is 7.5. Our middle side here is 6.25. So I know that triangle A has to match up with Z. B falls between our smallest side and our longest side in the first triangle. So the smallest side here and the longest side is here. So I know my next one is Y, which means our last one is X. So again, you want to match. And we matched by looking at the sizes. Okay. In the figure below, these lines are parallel. XS is 6, YS is 7, RY is 16. What's this length? Again, just keep it simple. This line, part over part, equals part over part. I also told you that you could add. So you could definitely add if you want, but why add and make our life hard? I'm pretty sure that's 96. Let me double check. Clear. 16 times 7. Nope, I'm glad I double checked. 112 divided by 7. Nope, what did I do wrong? That's what I did wrong. 16 times 6 is 96. I overjumped. 7x equals 96. Divide 96 by 7. And we get something ugly, which is 13.71. Next one, which type of transformation does not preserve distance? Not distance. Obviously, that's dilation. A sec point has an endpoint at 1025. It undergoes a 20% dilation centered at the origin. What is the new thing? Remember, 20% is the same thing as 0.2. So what will this be, a reduction or an enlargement? Because it's 20%, it's getting smaller. If you had $100, 20% of $100 is smaller, so it's a reduction. And then all we're going to do is multiply each one of these numbers times 0.2. 10 times 0.2 equals 2. 25 times 0.2 equals 5. I'm pretty sure. Let me just double check. So our new point will be 2, 5. And obviously it's a reduction because this number is less than 1. Next, we've got ABCD. is the dilation here? What's the center of dilation? What's the scale factor? Remember, we connect the points. So this will be one line here, connecting the D's. If we connect the F's, it's right here. Connect the B's, connect the C's. So this is our point. Our center of dilation is at -4, -1. Our scale factor, I just like to look at straight lines. Our first line was 4. So our old was 4 for the length of B. Our new is 2, counting 1, 2. So remember, new over old, 2 over 4 reduces to 0.5. Down here, just remember to match it, AB, so A prime, B prime, CD, D prime, F prime. You got to always make sure that they match on the bottom. Next. Last few. Yeah, you're getting that. Okay. Definitely watch this over again because I know I'm moving fast. Maps below, 51st Street, 52nd are parallel. Charlie walks from point A to point B. Walks this way. You walk directly from point A to point C. You walk this way. How many more feet did Charlie walk than you? So basically we have to find this. So let's just match it up. We'll do, first I'll use this information, 600 divided by 300 equals x divided by 500. 300x equals 30,000. Divide, x equals 1,000. What did I miss? 4 zeros, 300,000. So now we know this is 1,000. Now, most of you probably just noticed 300 times 2 gave me 600. So you might have just done 500 times 2 to get 1,000, which is totally fine. So Charlie had to walk from A to B to C. So he walked 1,200 feet plus the 300 feet plus the 600 feet. So if we add that all up, 2,100 feet. You walked from A to here, which is 500 plus the 1,000. So you walked 1,500 feet. 2,100, minus 1,500 is 600 more feet. Now, I technically did not show you a problem exactly like this, but you can handle it. Park Avenue is perpendicular to 51st Street. Is Park Avenue perpendicular here? Yes, because of corresponding, because the sides are parallel, or the lines are parallel. You're making a boxcar every 12 inches of the model. Matches 1080 of the actual, fill in the missing. So let's just find the ratio. Remember, it is new over old. So I'm going to type in my calculator, 1080 divided by 12 and get 90. So I have to multiply by 90 to go from old to new. I multiply by 90. And to go from new to old, I divide by 90. Okay, so the actual length is 600. So what's the model length? So I'm going to take 600 if the actual length is 600, divide it by 90, and I get 6.7 inches. For my actual height, to go from the height of the model here, remember we just multiply by 90, so this is 180 inches. Given, I think we did this one in class, A matches to E, B matches to D, C matches to C. Okay, it wants us to find EC. So E would means, in order to find EC, really we need AC. So here's our EC over AC. So that gives us X over 6. And then I just like to do the bottoms because they're easier. So DE over AB, which is 19.8 over 9. And then we cross multiply. So we've got 9X. Hi. Yeah, I have it over there. I'm recording a video right now for my students. Oh, wait, what's it over there? Okay. Oh, here it is. Okay.
Yeah, just sit down and see it. I'll come back.
All right. Appreciate it. Thank you so much. All right, I'm back. Yay, hi, I'm back. Okay, so then we do 9x, 19.
I'm having trouble connecting to the internet.
Oh, now Alexa's talking. It's so exciting.
Alexa app.
19.8 times 6 gives you 118.8 divided by 9 gives you 13.2. Next, down here, here's our triangle with these vertices. Which information is similarity to the original figure? 2, 2. Oh, this is already graphed. Let's see. Over 2 down -2. Over 3 down -6. So this isn't it because this is just a reflection, which is congruent. Here we have -2. So that was choice A. Next, we have -2, +2, -3, +6. Again, this is turning into a reflection. Now we've got 1 over 1 down -1, 1.5, -3, which is down here. So as you can see, this shape got smaller. Here's a hint. If there's decimals, it's the answer because decimals mean it was multiplied by a number less than 1. All right, so that is pretty much it. I will just show you this real quick. Don't forget to look for parallel lines, corresponding angles, alternate interior angles, and vertical angles. Also, we've got the reflexive property, you know, for lines, but you can also do the reflexive property for angles, especially if they're on top of it. You'll use this with vertical angles. Nope. Yep, you'll use this if you're giving a proof and they don't give you parallel lines. If you have a parallelogram, don't forget parallel lines means you have to do something with it. If it looks like this, you'll do alternate interior angles. If it looks like here and it says parallel, then you'll use corresponding angles. It has to say the word parallel. If it doesn't, then you're going to be using the reflexive I just talked about. And then don't forget about our similarity bow tie, where we've got vertical angles no matter what. But if these lines of the bow tie are parallel, you also have alternate interior angles. And any proof I'm going to give you is going to have angle similarity, which means two angles and a triangle are congruent. Yay, that's it. You guys are awesome. Catch you later. Ciao.